What are data centers? Well, data centers house a variety of computing equipment, such as large and small computers, servers, storage media, etc., as well as increasingly telecommunications equipment. These can be switching equipment, etc., that handle calls, cell phone calls. So all of these, of course, are faced in some ways with the same types of problems as far as their energy usage. These types of facilities use increasing amounts of energy, and much of that energy actually is utilized for cooling purposes. Some of the larger facilities can be as large as 11 acres of contiguous space and can consume as much as 20 or 30 megawatts of electricity. It turns out that about anywhere from 20 to 50% of that energy actually goes towards cooling. And so if one can reduce these cooling costs, that would help in terms of tremendous amount of energy savings. It turns out that currently for commodity servers, in about 1 or 2 years, you end up paying more for power and cooling than the cost of the server itself. So therefore there is a strong motivation to reduce energy consumption for cooling. And this particular lab focuses on these types of issues. About 10 years ago, Georgia Tech initiated a program on energy management research in data centers. We formed a consortium for energy efficient thermal management, or CEETHERM, laboratory about 10 years ago, to focus on improved cooling and overall reduction in energy consumption for cooling purposes in data centers. The CEETHERM laboratory involves participation not only from faculty such as those that are involved in cooling, but also now from other schools such as the College of Computing, where we are doing joint research with them in managing or co-optimizing the consumption of energy for cooling, as well as for powering the machines themselves for carrying out the computing operations.
I'm studying flow field in a data center using particle image velocimetry, or PIV technique. Air cooling is one of the most common approaches used for thermal management of data centers today. Hence, it is critical to measure the flow field coming out of a perforated tile as well as at the entry of the rack. CEETHERM Data Center Laboratory has set up one of the first particle image velocimetry setup to measure airflows at eye level. In a PIV system, laser beam is converted to a light sheet which illuminates the area where we want to obtain the flow field. The region is seeded using micron-sized particles which scatters the light, and this light is captured using CCD cameras. We have 2 laser light sheets separated with a time delay, and the distance traveled between these 2 time delays is obtained using post-processing of the images captured by the camera. Once we have the distance traveled as well as the prescribed time delay, we can obtain the velocity field using this system. The total flow field is obtained by traversing the camera as well as the laser system along the length of the rack, and we obtain the complete flow field by stitching together all the sub-regions. Here is an example of flow field obtained using PIV system at eye level. In case 1, we don't have any flow coming out of the tile. So all the flow is sucked through from the top of the aisle and from the side of the aisles. It will be noted that from top of the aisle, the hot air will come and it may increase the temperature at the inlet of the server. In case 2, we have 20% of the air flow rate requirement of rack coming out of the tile. In this case, we see that only half of the servers get the cold air coming out of the perforated tile, and top half of the server are getting hot air recirculated in the room. In case 3, as we increase the air flow rate through tile to 60% of rack air requirement, we see that some of the air is directly shooting out from the top of the aisle. We also see a recirculated region on the bottom of the rack. So these studies show that PIV system is very useful in predicting as well as evaluating the flow field inside the data center and coming out with strategies which are useful in thermal management of data center.
Some of the other CEETHERM data center capabilities are the high level of instrumentation of the data center at different length scales up till the CPU level, and this requires a substantial amount of data acquisition and logging for all these points. As a point of discussion, let us consider the grid-based measurement sensor system that consists of 1,000 thermocouples that measure the air temperatures across the data center, racks, and equipment. With these data points, we can actually plot and visualize the temperature map of the data center. Another distinct capability of the CEETHERM data center is the ability to switch between airflow schemes for raised floor data center. The current configurations for the airflow schemes are downflow, upflow, and airside economizer with the downflow.
Hello, I am working on reduced order modeling framework for data centers. Reduced order modeling framework is potentially very useful for delivering higher efficiencies in data center energy uses, particularly in a scenario of dynamic power uses. For that purpose, we developed a proper orthogonal decomposition based reduced order model. When we compare our model with corresponding CFD model, we found that our model is 2 orders of magnitude faster than corresponding CFD model without compromising solution accuracy.